Hello everyone, welcome to our video tutorial on setting the offset angle on a Swerve drive for an FRC robot. In this tutorial, we'll walk you through the entire process step by step so you'll be able to fine tune your robot's Swerve drive for optimal performance. Let's get started. Part 1. Understanding offset angle and its importance. Before we dive into the actual process, let's briefly discuss what an offset angle is and why it is important. The offset angle is the angle between the Swerve drive module's zero position and the robot's forward direction. This angle is essential to ensure that your robot can move in the intended direction, especially when strafing or rotating. By properly setting the offset angle, you'll make your robot's movement more efficient and precise. On the slide here, we have the robot's forward direction, which are the way the wheels are pointed, and we have the encoder's zero position. The offset angle is the angle between these two. Part 2. Gathering the necessary tools and software. To set the offset angle on your Swerve drive, you'll need the following tools and software: a laptop or computer with the Phoenix Tuner software installed, an FRC robot with the Swerve drive system, and you'll need a USB cable with an Ethernet connection or remote connection from your laptop to the robot's RoboRio. All the download links will be in the description, so feel free to check those out. Once you have everything ready, let's move on to the next step. YAGSL supports thrifty encoders, through bores, and generic duty cycle encoders, not just scan coders, making it perfect for any Swerve drive configuration. YAGSL supports other absolute encoders and no absolute encoder configurations as well. However, in this tutorial, we'll be using CTRE's absolute CAN coders. Part 3. Connecting to the RoboRio. First, power on your robot and establish a connection from your laptop to the RoboRio. Next, launch the Phoenix Tuner software on your laptop. Once Phoenix Tuner is running, click on the Connect to Device button to establish a connection with the RoboRio. You should now see the connected device and its details on the screen. If you have issues connecting to the robot, try using the 172 address in the drop-down if you are connected to the robot over USB. If you're connected over Wi-Fi, try 10.yourteamnumber.2. As you see here, I'm affiliated with BronkBots, which is team number 3481. So as you see at the bottom right here, we have 10.34.81.2, and that should be for wireless connections. We recommend using the USB cable and selecting 172.22.11.2 to avoid any networking issues. A quick way to check if you have communications with the robot is to open up the FRC driver station, and you should be able to see the connected device and its details on the screen. As you see here, we have communications with the robot, as indicated with the green box next to it. Part 4. Setting the CAN coder ID using Phoenix Tuner. If you haven't set your CAN ID CAN coders yet, I will show you briefly how to set them up. If you've already set them up, go ahead and skip to the timestamp displayed on the screen right now. Let's go through the process of setting the CAN coder ID using Phoenix Tuner. Properly setting the CAN coder ID ensures your robot can correctly communicate with the Swerve module's encoders. So first, in Phoenix Tuner, click on the CAN Devices tab, as shown right here. Number 2, locate the CAN coder you want to set the ID for and click on it to select the device. In the device configuration section, you can find the CAN ID field, as shown right here. Enter the desired CAN ID for the CAN coder, making sure it's unique and doesn't conflict with other devices on the CAN bus. Click on the Apply button to save the new CAN ID, which would be shown right here, and make sure your CAN ID software is up to date. Remember to update your robot's code to reflect the new CAN ID for each CAN coder. That's it, now you've successfully set your CAN coder ID using Phoenix Tuner. Part 5. Determining the offset angle. Now we'll determine the offset angle for each Swerve drive module. To do this, follow these steps. Place the robot on blocks, making sure all wheels are off the ground. Manually rotate each Swerve drive module to align it with the robot's forward direction. As you see here, I like to take a piece of straight-edged metal and line it up with the wheels to make sure that they both are in the forward direction, as eyeballing it can sometimes produce poor results. In Phoenix Tuner, navigate to the Self-Test Snapshot tab and select the appropriate absolute CAN coder ID. You should be able to see all 4 of your CAN coders with their respective CAN IDs next to them, like shown in Figure 2 right here. Click the Take Snapshot button at the bottom and observe the integrated sensor position value displayed in the snapshot. This value represents the offset angle for the selected module. And then finally record the offset angle for each Swerve module. As you see here, we will select our CAN coder. We come down to the bottom and click self-test snapshot. And the integrated sensor position is what you want to be recording down for all 4 of your modules. Part 6, applying the offset angle to your robot's code. So I've opened the FRC.YAGSL example project, and I will navigate to Deploy, Swerve, and Modules. So let's go ahead and open up back left, back right, front left, and front right. As you see here, you should be able to see your encoder, type, and ID. If you come down to the bottom, you should be able to see your absolute encoder offset, which is where you'll be inputting your recorded offset values. If you need to change your ID, this is where you'll do it in the code. The process should be the same for each module. After you've added all the offset angles for your Swerve modules, deploy the updated code to your RoboRio and test your robot's movement. If everything was done correctly, your robot's Swerve drive should now move more accurately and efficiently. As you see here, we have our FRC.YAGSL tutorials, public Google Drive. Within it, you'll be able to find our slideshow and some additional links that may help you. Congratulations, you've successfully set the offset angle on your robot's Swerve drive system. We hope you found this tutorial helpful. Remember to always test and fine-tune your robot to achieve the best possible performance. If you have any questions or need further assistance, feel free to drop a comment down below or reach out to the FRC community for support. Don't forget to subscribe to our channel for more FRC related tutorials and tips. Good luck with your competitions and happy building.